There we go. Okay, it'll probably ask you if you want to stay. So there are two forms of quadratic functions that are useful. One is the vertex form, and one is the standard form. And the standard form is ax squared plus bx plus c. So you might be familiar with the ABC because that's part of what is in the quadratic formula. But here, this A in the vertex formula is the same as the A in the standard form. But the other letters are different. So H is the x coordinate of the vertex, and K is the y coordinate of the vertex. So let's look. First of all, we're going to see if we can figure out what A, H, and K are. So what number is in front of the parentheses here?
1.
-1, right.
-1.
Good. So A is -1. And let's be really careful about this form. It's x minus h quantity squared, and we have x minus 3. So what is h? Is it -3 or +3?
It's -3.
And this is the weird part. It's going to be positive. H has to have a negative in front of it in order to be positive. If H has a positive sign in front of it, it will be negative. It's kind of weird.
Yeah.
And then we've got K, and K is straight up. What you see is what you get. So K is going to be +4. And that means that the vertex will be 3, 4. And so we go over 3, down 4, up 4. I don't know what planet I'm on. Okay, here we go. And vertex just means the place where the function changes direction. So with a quadratic, it's either the place where it ceases going up and begins to go down, like it will be in this example, or where it ceases going down and begins to go back up. So the vertex is where it changes direction. And the way that we know that the vertex is the top point of this function is that A, the number out front, tells us whether the graph is going to go up or down. So if A is positive, it will be the smallest value and the graph will go up above it. And if A is negative, then the vertex will be the highest value and the graph will go down below it. And we have -A. So our graph let's cheat. Let's plug in some numbers. So we have negative x minus 3 squared plus 4. And we already have 3 comma 4. But let's see if it really works. So when x is 3, let's see, that'll give us 3 minus 3 squared plus 4. And what is 3 minus 3?
0.
Good. And 0 squared?
Yes.
And then a negative 0. Is that the same as positive 0?
No.
And so, and then adding 4, we just get 4. So hey, that's cool. Let's see what we get if we plug in 0. So we'll have 0. Everywhere that there's an x, I'm going to plug in a 0. 0 minus 3 all squared plus 4. So let's see. Let's work on the inside out. 0 minus 3.
0.
Negative 3.
Negative 3.
Okay. And then
I said 0. I don't know if I'm correct.
0 minus 3 is negative 3. And what is negative 3 times negative 3?
9.
9. Positive 9.
And then we've got negative. So that's how we end up with negative 9 plus 4. So this double negative is confusing. It's important to add the two numbers and square before we add the negative on the outside. And so what do we get? What is negative 9 plus 4?
Negative 5.
Good. And the cool thing about the vertex is that the entire graph mirrors from one side of the vertex to the other. And this mirror is the axis of symmetry. And the equation for the axis of symmetry is x equals h. Well, our h was 3, so it's x equals 3. And that's the line that everything to the right of the line will mirror everything to the left of the line. Which means if we go 3 places to the right of this line, so 1, 2, 3, we will also get a negative 5. And let's just check to see if that really works. Let's plug in 6. 6 minus 3 all squared plus 4. And what is 6 minus 3?
Positive 3.
Good. 3 squared is
9.
9.
excellent. And then what do we do with the negative that's outside?
Negative 9 will be negative 5.
Okay, so we really do get the same value. So any point that we find to the left of this we'll have a matching to the right. So let's go ahead and plug in 2 more numbers. Let's plug in 1 and 2. So there's 1 minus 3 all squared plus 4. And what do I have to do first?
1 minus 3.
Good. And that is
Negative 2.
the
4.
good. And now we deal with this negative. So now we have what kind of value?
Negative 4.
So negative 4 plus 4. We get
0.
when we get a 0, where will the mirror point be? How many places are we to the left of the line?
2.
2. So how many places should I go to the right?
2.
And we don't need to plug in more points, but I really want to plug in this minus 3.
Negative 1.
Negative 1 squared.
1.
1.
Good. Is
Negative 1.
good. Negative 1.
3.
So that gives us 0.2. Which other point do we have? We have a point one place to the left of the axis. What mirror?
4.
Good. And that's nice because it halves the work that we have to do. It's important to note that a quadratic is smooth at the vertex. In other words, it does not have a corner. So try not to draw quadratics like a V upside down or right side up. Make sure to make it look more like a U. Okay, but we just spun our wheels to do nothing that was asked for. So we found the vertex right away. Let's find the X and Y intercepts using the methods here. So to find the, and I guess I didn't put it here, so I'll make sure that it is in the notes that I publish. So to find the x-intercept, set f of x equal to 0 and solve for x. And the reason that we set f of x equal to 0 is that f of x is y. And we want y to be 0 so that we're on the x-axis. Well, let's see. That means I've got, we started with f of x equals negative x minus 3 all squared plus 4. And I'm setting f of x equal to 0. So I don't have to have this f of x there anymore. But I want to find x. So One way that we can do this is by getting everything that isn't x on the opposite side of the equal sign from x. So where do you want to, what do you want to move?
The 4.
And how do we move a positive 4?
Subtract 4 from both sides.
So that gives us -4 is equal to, and I'm going to write this negative sign as a -1, just to help me remember what it means to have that negative out front. And now I don't want anything out front. I want to try to get to x. The first step of getting to x is dividing out anything in front of the parentheses. So what can we divide both sides by?
By 1?
Good. On the left side, -4 divided by -1 will give us
+4?
beautiful. And -1 divided by -1 is +1.
+1, yes.
Yeah, we're not gonna write. All right, so we've got 4 is equal to x minus 3 all squared. You know that adding is the opposite of subtracting, and dividing is the opposite of multiplying. What is the opposite of squaring?
Square root.
Good. So we want to take the square root of both sides. Anytime you take the square root of both sides of an equation, you must put a plus or minus sign in front of one of the sides. Now, what is the square root of 4?
2.
And this plus or minus is still there. What happens if we have got x minus 3 squared and a square root?
It turns into x minus 3.
Good. So they cancel. We just have x minus 3. And to find the two values of x, we're going to first use the plus sign, and then we'll use the minus sign. And that will give us two values. Let's we use the plus sign, we'll have 2 is equal to x minus 3. How can we solve for x?
We divide it.
Dividing would mean that there's something in front of the x, because dividing is the opposite of multiplying. What is the opposite of subtracting?
Adding.
Good. What are we going to add both sides? What will we add to both sides?
3.
And so we get that 5 is equal to x. And remember, we set f of x equal to 0. So the point that comes from this is x is 5, y is 0. So the point is 5, 0. And if we look up here, we did indeed have an x-intercept at 5, 0. So now let's use the minus sign. So we've got -2 is equal to, does that show up?
Yes.
Okay, -2 is equal to x minus 3. And how can I solve for x?
Add the 2.
Just add 3 to both sides. Negative 2 plus 3.
One.
Good. So we get that x is equal to 1. And I remember that I let y be 0. So this is the point 1 comma 0. And it's nice because that's exactly what we got before. We got that point from plugging in points, plugging in values of x. But sometimes the best way to find the x-intercepts is to do what we just did, to set y equal to 0 and solve for x. To find the y-intercept, we do exactly the opposite. So for the y-intercept, we set x equal to 0 and solve for y. Okay, weird. So we've got y is equal to negative 1 x minus 3 all squared plus 4. And what am I setting equal to 0 this time? Which variable is going to be 0 this time?
X.
Good. So we've got y is equal to negative 1, then 0 minus 3 all squared plus 4. And what should we do first?
The 0 minus 3.
Good. And 0 minus 3 is? Oops.
Negative 3.
And negative 3 squared?
Positive 9.
And this negative will come down. And we'll have negative 9 plus 4, which is?
Negative 5.
Negative 9.
So the point is going to be, we said y was negative 5, x was 0. So this point, the y-intercept is 0 comma negative 5. And if we look, that's exactly what we found. But the way to find the y-intercept analytically or algebraically is to let x equal 0 and solve for y. So I think that's all of the stuff we wanted to do for this question. So do y'all have any questions about the vertex form?
No, I got pretty much all of that. I get lost in the graphing.
Were you lost?
In the graphing, I have no idea why. It just confuses me.
So this didn't make sense, or?
It made sense the way that you showed it.
Say it again?
It did make sense the way that it was shown.
Yes.
Okay. Yeah, sometimes Alex skips a lot of steps or crucial steps. Okay, well, like we said, the other form of the quadratic equation is the standard form. Ax squared plus bx plus c equals 0. And it's important that the a can't be 0, because if a is 0, then we just have bx plus c, which is a line. It isn't a quadratic anymore. To find the x-intercepts, we can use the quadratic formula, or we can factor the quadratic and set each factor equal to 0. Then we can use the zero product rule. If the product of two things is 0, then one of the things has to be 0. To find the vertex, if we're given standard form, the x-coordinate of the vertex, so the x-coordinate of the vertex is negative b divided by 2a, and the y-coordinate of the vertex, you just plug in the number that you found for the x-coordinate, so negative b over 2. And that's what this formula means. So let's do that. Let's figure out the vertex for example 2. And we should answer the first question first. So I'm skipping so many steps. What is A, what is B, and what is C? Remember that A is in front of x squared, B is in front of x, and C is the constant.
So x squared will be a.
So the number in front of x squared would be A.
It will be 1.
Good. And then B?
B will be 2, negative 2. And then C will be negative 3.
Beautiful. So we know that the x-coordinate of the vertex is negative b divided by 2 times a. So I'm going to be very careful with all these negatives not to skip any steps. What is b?
Negative 2.
And a?
And A will be 1.
Beautiful. So if I multiply all of that out, I've got negative 2.
And that will be negative 1.
What is negative times negative 2?
Positive 2.
Good.
Oh,
And in the denominator, we'll add
2.
Good.
Positive.
And 2 divided by 2?
1.
Gorgeous. So the x-coordinate of the vertex is 1, and that means that the axis of symmetry is x equals 1. Groovy. To find the y-coordinate of the vertex, we're going to plug 1 into the function. So we have f of x is x squared minus 2x minus 3, and we are plugging in 1. So f of 1 is 1 squared minus 2 times 1 makes 3, and 1 squared?
1.
1.
Of 2.
Minus 2.
And how do we adding or subtracting 3 things? Which order do I go in?
-1 would be -4.
You go from left to right. So 1 minus 2.
-1.
Eight.
-4.
And that means that the vertex is at 1 comma -4. So using the notation that we had from the vertex form, we would say that H is 1 and K is -4. Since A is positive, so here A is equal to 1 and 1 is greater than 0, that means that the parabola, the quadratic function, opens up. That means that -4 is a minimum. So the minimum is -4. And we're going to open up. And now let's go ahead and figure out the x-intercepts and the y-intercept. And let's do the x-intercepts 2 ways. Let's factor, and then let's use the quadratic formula. So we've got f of x is equal to x squared minus 2x minus 3. To find the x-intercepts, we always let f of x be 0. And now we want to factor x squared minus 2x minus 3. How do y'all like to factor these?
Okay. We start with the x squared.
Okay. What do we do with it?
Like you taught me before, we put a 1 in front of it.
Okay.
And then 1 plus 1 is 1. I mean, 1 times 1 is 1. Am I correct?
1 times 1 is 1. But that's not what we do here. So let's just
We're gonna get rid of the 3.
Yes.
We're gonna add 3 to both sides.
you can do it that way, but it's easier to factor. So to factor this, remember that A is 1, E is -2, C is negative. After this, I want to find 8 times. I want to find
That's right. Yeah.
8 times C is going to be the product. B will be the sum. And what is A times C?
3.
No, it's -2.
And B,
You said, okay.
any two numbers, anything you can think of that would give you a -3.
-2.
Multiplying.
1 times -3.
Good. So 1 times -3 is -3. So that's the product. So now we're going to add them. 1 plus is
Equals -2.
Yay, that's what we want. So we're going to this 1 and -3. Write it as and that -2 from the 2x, it's 2x there with 1x minus 3x. But when you factor by grouping, the middle number, if you can make the middle number positive, life will be happy. So I'm going to put the 1x second. I'm going to rewrite the quadratic. 0 is equal to squared. I'm going to put the negative bx x plus 1x. So the x squared term stayed, the c term stayed, but the b term became 2 terms. And the middle sign is positive. It is fine if the middle sign is negative, but it's a little extra one. Okay, so by grouping, we want to find something in common with the 2 terms and something in common with the last 2 terms. So what's common with x?
The 3.
The x, what do they both have though?
I can't hear you.
What do they both have? They do not both have a 3, but they do both have something.
X.
X times x in the first one and negative times x in the second. So they both have x. And that means we're left with 1x in the first one. Negative. What's common between x and -3?
X and
Is there anything?
It's essentially the same formula, correct?
Yeah, so one is the only both exactly right. The fact has to match. X minus that matching is going to we're going to write down everything that's left. Well, from the first whole term, we've got an x and then a plus sign. The second whole thing, we just have a 1 left. And that's it. X minus 3 times x plus 1. Did that make sense?
It makes sense. It's just a little rough getting there.
Yeah, there's a lot to these questions. Okay, but we're not done. We set y equal to 0 So now we have 0 equals x minus 3 times x plus 1. We have the product of two numbers equaling 0. And think for a second, is there any way you can multiply two numbers and get the answer of 0 without one of the numbers being 0?
No.
You know what I mean? Can you multiply any numbers together and get 0? Or does one of the numbers have to start out?
Has to be 0.
That's right. And that's how we're going to this number is
3 minus, yeah.
and in both cases, it's got both zeros. Those are our x-intercepts. So we have -1, 0, and 3, 1. We also need the y-intercept. Well, to find the y-intercept, we let x be 0 and we solve for y. So let's see. F of 0, that'll be 0 squared minus 2 times 0 minus 3. And what do we get?
-3.
But we let x be 0, so this is the point 0 comma -3. So the y-intercept is here. Now, I've already got the axis of symmetry. The two x-intercepts are both 2 places away from that axis of symmetry. But I only have one point in the lower quadrant to the left of the axis of symmetry. Can I put in another point without doing any work? In other words, since at this point at 0, -1 place, now if I go place on the other side,
Yes, to the right,
yes.
-3.
So we've pretty much answered all the questions, but let's go through and see. Finding the vertex helped us do a lot of stuff. We were able to find the axis of symmetry, x equals the x component of the vertex, which we can write v sub x, or we can just write h. And in this case, that number is 1. The min or the max, well, since a was positive and the parabola opened upward, then k, the y-coordinate of the vertex, will be a minimum. So our min is -4, and that's always k. And we could also write that as the y-coordinate of the vertex. We're going to use this information again to write the domain and range. So the domain is all the possible numbers we can plug in. And if you think about it, we can multiply any number by -2, we can subtract 3 from any number, and we can square any number. So the numbers that we're allowed to plug in are all the numbers. So the domain of f starts at negative infinity and goes all the way to positive infinity, which means it's the entire x-axis. And a way that you can write the entire x-axis is an R with a double bar, and that stands for all real numbers. Now, if we look at the graph, we don't have all possible numbers on the y-axis. We have a lowest value. So k gives us the lowest value, and then we go up from there. So the range, all the possible outputs, the lowest value is -4. There's no highest value, so we go all the way to infinity. And I put a smooth indicator here because we don't ever get to infinity. It isn't a number, it's an idea. We do get all the way to -4 because the graph touches y equals -4. So that's why it's squared off there. If I had a graph like this, where there was a hole at the lowest point, and it looks like the lowest point is -2, we would say that the range of this, we'll call it G, the range of G is open, -2 to infinity, open. And that's because we don't ever get all the way down to -2. We get as close as we want, but we don't ever get all the way there. Did we answer all the questions? Oh, I wanted to do one more thing. I wanted to find the x-intercepts using the quadratic formula. Because sometimes it helps to use the quadratic formula on an easy function where the numbers are not horrible. So we've got x is equal, I'm going to write this. X is equal to -b plus or minus the square root of b squared minus 4ac all divided by 2 times a. Is there any part of this formula that looks more complicated than the other parts?
No.
The square root?
Yeah. Let's figure out the square root part first. So we want to see what is b squared minus 4 times a times c. And we said that b was -2. Is that right?
Yes.
Good. And a was 1. What was c?
-3.
Beautiful, thanks. What is -2 squared?
Positive
4.
4.
Let's see, let's do this in 2 steps. 4 times 1.
4.
4.
And 4 times
-12.
-12.
It turns into a positive, correct? You're adding 4 to -12, which is 8. Or, I'm sorry, -8. Oh,
Isn't it 6? By doing this separately, now it's not a big deal to find the square root of 16. And that number is 4. The plus or minus is in the formula. X equal to negative, and I'm going to put b in. I'm going to put b in here. The square root of b squared minus 4ac in here, and a in its spot. B was -2. B squared minus 4ac, the square root of was 4. And A was
1.
So let's take care of some of this stuff. -2.
That turns into a positive.
We still have a plus or minus. It's multiplied. And now things just take. We'll have 2 plus 4 divided by 2.
6 divided by 2, which equals 3.
Beautiful. And using
-2 divided by 2, which equals -1.
1.
beautiful. And what y value goes with these numbers? We're finding what y did. So yeah, in both cases, y is 0. So we get 3 comma 0 and -1 comma 0. And yay, that's exactly what we got using that. That's I'm going to stop the recording and start it again, just so that it's not too long.